All right, so this is J16, which is continuing on with factoring, and this one's called special factorizations because what we're going to do is focus on the two-term polynomials, okay? So for two-term, well, first of all, we want to make sure we always look for greatest common factor. That's always step one, okay? After greatest common factor, if you have two terms, what you're looking for is either a difference of squares or a sum or difference of cubes. And I notice there is a typo. This second subtraction sign right here should be a plus. So go ahead and change that. If your paper isn't updated, go ahead and make sure that is fixed, okay? So a difference of squares means that you have two terms in your polynomial and both terms are perfect squares, okay? So this could be something like x squared minus 25, okay? Both of those are perfect squares because what I would have to square to get this value is an x. What I would have to square to get this value is a 5. Okay, so these are what we call the bases, right? This is what we have to square, these two bases, in order to get these two values. So because we're subtracting them, it's called a difference of perfect squares, okay? So a difference of squares, if I know what these bases are that are being squared, it will always factor into the first base plus the second, and then the first base times the second. So if I know that the base of my first perfect square is a, and I know the base of my second perfect square is b, then all I do is plug it into this formula. Okay, so for my little example right here, this would be like our a and this would be like our b. Okay, so that means that this would factor into x plus 5 times x minus 5. Okay, so all you're required to do is 1, know the formula, okay, and 2, be able to identify what is the base values that we're going to plug into that formula, okay, and then that's fully factored. So let's look at another one. If we have a sum of squares, notice it's not factorable. So this would be something like if we had x squared plus 25, okay, x squared plus 25 would be not factorable. There's nothing in common and we have no formula for factoring a sum of squares at this point, okay? So that is sum and difference of squares. A difference of squares factors using this formula, okay? A sum of squares we can't do anything with. So let's go ahead and look at when we have cubes. Okay, so cubes is kind of the same idea. It's just instead of having perfect square terms, we have perfect cube terms. Okay, but we do it the same way. We still identify what is the base that's being cubed, and then we use those a and b bases, our first base and our second base, to plug into these formulas. Okay, now you are responsible for knowing these formulas. Okay, so if you are a highlighter or a note card maker or something of that sort, these are all things you're going to be responsible for knowing. I'm not going to ask a question like state the difference of cubes formula. I'm not going to give you something like that on a test. However, I will give you, you know, possibly a two-term polynomial that is a sum or a difference of cubes, and you would have to know this to know how to factor it. Okay, so let's look at a couple examples. I'm actually going to start with this one over here. If we look at 64x cubed minus 25y cubed, just looking at the exponents, if I'm trying to decide is this a difference of squares or is this a difference of cubes, I just look at the exponent. I have 3's here, okay? If I had 3's, 6's, 9's, 12's, things that 3 goes into, it's most likely going to be cubes, okay? If it's an even number, then that's when we would kind of look at it to see if it's a square, all right? So I'm already thinking that this is going to be a difference of cubes, okay? Because I know I have cubic exponents, right? And it's being subtracted, so that's how we know it's a difference. So I'm going to be using this formula. But before I can use that formula, I need to identify what my A and B, what's my first base, what's my second base. So what would I have to cube in order to end up with 64x cubed? Well, I would have to cube 4 to get 64, and I would have to cube x to get x squared. So this is my first base. This is like my a, what I'm going to be plugging in for a up here, right? And then to determine what I have to cube here, the cube root of 125, or the number times itself 3 times, that gives us 125, is 5. And the letter we have to cube here to get y cubed is y. So this is like my second base. Okay? So the difference of cubes formula states that I take my first base and I subtract my second base. So that means I'm going to do 4x minus 5y, right? First base minus second base. Then in this next quantity, it says to do a squared. So that means my first base squared. So I'm going to take 4x and square it. Then it says to take my two bases and multiply them together. So I'm going to do 4x times 5y. And then my last term here says to square my second base. So I'm going to square 5y. Okay. And now this is pretty much my answer. I just need to do some simplifying. So this is 4x minus 5y. When I simplify inside here, 4x squared gives me 16x squared. 4x times 5y gives me 20xy. And 5y squared gives me 25y squared. And the good thing about sum and difference of cubes is that once you have plugged it into the formula, this is never going to be factorable. So you don't have to worry about checking it to see if it will factor further. Okay, whatever this leftover polynomial is here will always be prime. Okay, meaning it does not factor further. Okay, so we kind of okay with the process here. We're looking at the two terms that were given. We determine if we're looking at squares or cubes. In this case, it was cubes, right? And then we determine what bases do we have to cube in order to get the two terms we have. Once we know those bases, then we're just plugging them into the formula for whichever cubes we're dealing with. Here it's a difference, so we use the second one. Okay, let's look at another one. Let's look at this one. Now this one's a little bit confusing, right? Because it's an x to the 6th plus 1. So 1 is actually a perfect square and a perfect cube. X to the 6th, I could write that as a square, right? I could write this as something x to some power squared, or I could write it as x to some power cubed. So this one could kind of go either way. So I want to just think about it for a second. If I look at this and I want to make it into squares, okay? If I want to write this as something squared and I want to write this as something squared, okay, I can do that, right? Because I could take x to the 3rd power and square it, which would make these multiply together, right? So this is a perfect square. I could also take 1 and square it, and that would be the base for the second one. But what I'm ending up with, in this case, if I write them as squares, is I'm ending up with a sum of squares, right? And we don't really want to end up with a sum of squares because remember, a sum of squares, if we look back up here, is not factorable, okay? So even though it can be written as two perfect square terms, we don't want to use that option because it doesn't help us. It's not factorable, okay? So we're going to look at this one in a different light. So x to the 6th plus 1. So let's see if we can get a little bit further if we look at it as a sum of cubes. So that means I want to write this as something cubed and this as something cubed, okay? Because I'm hoping for a sum of cubes because we have a formula for that one, right? So what would I have to cube in order to get x to the 6th? Well, I would need an x squared, right? So that when I multiply those powers, I end up with a 6. So my first base, my little a here, is going to be x squared, okay? My second base that I have to cube in order to get 1 would just be 1. So my first base is x squared. my second base is 1. Okay, you don't have to label these with A and B. The reason I'm doing that is just so that you know where we're plugging these in the formula up here. Okay, so this is a sum of cubes, so we're going to use the sum of cubes formula. Okay. Okay. All right, so for our sum of cubes formula, it says to take my first base and add it to my second base. So my first base is x squared. I'm going to add it to my second base. Then inside my next quantity, it says to do my first base squared. So I do my first base, which is x squared squared. Then it says to subtract my two bases multiplied together. So I'm going to subtract my x squared times my 1. And then my last term is to add in my second base squared. So I'm going to add in my 1 squared. Okay? And then I just simplify. So my first quantity is still x squared plus 1. When I simplify this quantity, x squared raised to the second power gives me x to the 4th. Okay? When I simplify my middle term, I just get negative x squared. And my last term becomes positive 1. Again, I don't have to worry about checking to see if this goes further, because we know anytime we use the sum or difference of cubes, this leftover or our second quantity here is never going to be factorable. So we're done. Okay. All right, so this was a difference of cubes and a sum of cubes. Let's look at one that might incorporate a little bit more work. Okay. And I'm going to put this page here so I still have my formulas. You have them on your paper, but I'm going to put it like this so that I can see the problem I'm doing and the formulas. Okay. All right. So first step, always, 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 is look for a greatest common factor. And in this case, I have one, right? My greatest common factor, they both have a 7 and they both have a p. So I'm going to take out the 7p. And when I take out 7p, remember that's like dividing each of these by 7p, then the first term I would be left with just q to the 4th. Second term I would be left with a negative y to the 4th. Okay? So now I need to see, okay, what can I do now? I'm going to ignore my little 7p, but I'm going to put a little star so I make sure I remember to put it on my answer. And then I need to see what can I do with these. So I have two terms. Two terms tells me I'm looking for a difference of squares or a sum or difference of cubes. So I look at the exponents. My exponents are 4s. So I'm guessing that this is going to be squares, not cubes, right? So my difference of squares formula says I need to identify what the bases are that are being squared so I can plug it into first base plus second base times first base minus second base, okay? So let's see. Looking at q to the 4th, and I want to write this as a perfect square, what I would have to square to get q to the 4th would be q squared, right? So this is my first base. What do I have to square to get y to the 4th would be y to the 2nd. Oops. Oh, man. This eraser is crusty. Let's see if I have another pencil. Crusty eraser. Okay. Minus. All right. So now I can see this is my first base, this is my second base, and what I have here is a difference of squares. Okay. So I'm just going to rewrite this. I have my greatest common factor, which was 7p, right? And now I want to plug it into my difference of squares formula. Okay, it is factorable because it is a difference. So my difference of squares formula says to do my first base plus my second base, and then my first base minus my second base. So my first base is q squared, my second base is y squared. So this is going to factor into q squared plus y squared and q squared minus y squared. Okay. Now, unlike the difference of cubes formula, right, whenever we use the difference of cubes formula, I told you that these two, the second quantities are always prime, meaning we can't factor further. That's not always true when you do a difference of squares. So we are going to have to check to see if this guy will factor any further. Okay, what I'm noticing is both of these terms are perfect squares, right? This is, I could say the base of this is q and the base of this is y, but the problem I have with this is that it is a sum of squares. Sum of squares. And remember, a sum of squares, if we pull down our formulas here, right, a sum of squares is not factorable. Okay, so this one I can't go any further with it, even though they're perfect squares, because it's a sum, it is not further factorable. Okay, so let's look at this one. This one also has perfect squares, right? My base here is a q that I would square, right? My base here is a y that I would have to square, and it has the subtraction. So this one is a difference of squares. And a difference of squares we can factor further. Okay, so again, using the same formula of first base plus second times first base minus second, now using these two new bases that I just wrote. Okay, so again, I'm going to go ahead and right below, I still have my greatest common factor, 7p. I have the quantity that will not simplify, which is q squared plus y squared, right? And now I can break this quantity down by doing the first base plus the second, so q plus y times q minus y. And now I can't go any further. Right? So I'm going to go ahead and box that in. Whoop, my paper's about to fly away. All right, there are 3 for you guys to try, so go ahead and pause the video so that you can attempt those on your own, and then whenever you're ready to go over them, or if you get stuck, go ahead and unpause the video and we'll work through them, okay? All right, let's go ahead and look at the first one. The first one, we can see they're perfect squares, right? I'm looking at the exponent, it's a 2. So I'm thinking squares, and it's being subtracted. So I'm thinking difference of squares. Difference of squares we do have a formula for, so all we have to do is identify the bases. So what I have to square in order to get 16x squared is 4x. What I have to square in order to get 9 is 3. So my first base is 4x, my next base is 3. So I just plug those into the difference of squares formula, which says to do first base minus second and first base plus second. Okay, and it doesn't matter which order you put these quantities in. Okay, the 4x's need to come first and the 3's need to come second. But if you wrote the quantity that has the plus first and then the quantity that has the minus, that's totally fine. Okay, all right, let's look at the second one. The second one, I see a cube right away on the m. So I'm thinking cubes, which we have a formula for, so that's good. So we're going to look at for a sum of cubes. What I have to cube to get m cubed is m, so that's my first base. What I have to cube to get 64 would be 4, so that's my second base. So I'm plugging in m for my first base, 4 for my second base into the sum of cubes formula. Okay, so our sum of cubes formula said first base plus second base, and then in our next quantity, first base squared minus our 2 bases multiplied, plus my second base squared, and then we just simplify. Okay, all right, the third one was a little bit different because there was a greatest common factor, so hopefully you knew to take out your 3a squared. Once we take that out, our leftovers are perfect squares. Okay, so what perfect cubes. So what I need to cube to get a cubed is a. What I need to cube to get 8 is 2. All right, so this is a difference of cubes. So I'm going to plug a as my first base and 2 as my second base into the difference of cubes formula. So I went ahead and put my greatest common factor out here. And then my difference of cubes formula says to do first base minus second base. And then in my next quantity, first base squared plus my 2 bases multiplied together plus my second base squared. Okay, and then we just simplify. So that is the end of J16. Okay, so now we have all of our factoring methods completed. We know to take our greatest common factor out, and then based on what type of terms, or how many terms we have rather, we know what our factoring method should be. Okay, So y'all should now be able to complete J16. If you need any type of help, please let me know, and I will help you out.